Good day once again, my highly esteemed viewers. You're welcome back to class. Like in our first video we did on gas laws as it relates to elementary chemistry, which we normally call SS1 scheme, second term. We have another that we call that one part 1. Today we are going to have part 2 of the same gas laws. Remember, everything we are going to talk about today, they are going to be, we're going to talk about this season before the holiday goes off. Is going to be centered on gas laws. So even next year, it's still the same thing because the scheme of work is the same thing. And again, those of you preparing for WAEC private, WAEC major, JAM, they are still very, very vital, very important because these are elementary part of chemistry which they believe you should not forget. So let's go. So you see the first one, past questions part 2. Like I told you, we are going to do it in different parts so that when we are tackling one particular law, it's easier for you to understand it. But remember, after picking this example, you need to tackle other questions as it relates to those laws. And if there are areas you don't understand, you have the comment section to comment. And I promise I will do my best to answer on time. So, temperature conversion first, because before we do Charles law, because you need temperature to calculate Charles law. So, temperature conversion. First of all, to convert temperature, you have Kelvin equals degrees Celsius plus 273. Remember, the old unit of measurement is Celsius, but the SI unit, the current one we use to measure, is Kelvin. It doesn't have a degree on it. So this is the formula. And they said convert 700 Kelvin to degrees Celsius. 700 Kelvin to before you even substitute, you can make it subject to formula first. You say degrees Celsius equals Kelvin minus 273. So having this formula alone, we want to solve everything for you instead of memorizing different formulas, which may lead to confusion, except you are very okay with it. So you see it, 700 Kelvin, this is 700 minus 273. So let's see what it gives us. Remember, Kelvin to degrees Celsius, and that's what we are doing. So my beloved students, make sure you study very well so that on resumption in my school or other schools, you don't have more challenges because second term scheme usually very, very small. So when you have all these ones at your fingertips, you will make it easier for whoever is teaching you in your various schools so that you can be able to flow along. So 700 minus 273 gives you 427 degrees Celsius. So that's how you calculate that. Converting Kelvin to degrees Celsius, you remove 273 from it. Then the second one, this is question 1. Question 2, convert minus 50 degrees Celsius to Kelvin. You say Kelvin equals degrees Celsius minus 273. They say minus 50 degrees Celsius. Degrees Celsius plus 273. So let's see how it goes. Two, 7, 3 and 50, 223 Kelvin. So this is how you do it. Once you know this single formula, it can solve others for you. All you need to be doing is to substitute. I hope you understand what I'm saying. All you need to be doing is just to substitute. Anyone you are looking for, you substitute. So go through it very well because we are going to apply it now. We are applying it in Charles law, and a subsequent video again we apply it in general gas law. So let's clean this that you have. So that's how you convert it. Then the next question is state Charles law. Charles law by Charles law states that the volume is similar to Boyle's law. It's only direct and indirect. One varies, the other one is direct. Charles law states that the volume of a fixed mass of gas or the volume of a given mass of gas is directly proportional to its absolute temperature, provided temperature is kept constant. So, say volume directly proportional to its absolute temperature, pressure is constant. So, Charles law states that the volume of a fixed mass of gas is directly proportional to its absolute temperature if pressure is kept constant. So you can this is what the law says. When you want to express it in form of equation, derive equation from it, you can say V equals KT, where T is the proportionality constant. V over T equals K. So if you have initial volume and initial temperature, you can have it like this: V1 over T1, V2 over T2, because each of them will always equal to K. V1 over T1 equals K. Like V1 over T1 equals K. V2 over T2 equals K. So substitute the two. Now become V1 over T1 equals V2 over T2. That's how it's actually done. So this is the formula which we are going to be using. So this is how it was derived. V1 over T1 equals V2 over T2. Where V1, initial volume of the gas, everything is on gases. T1, initial temperature of the gas. V2, final volume of the gas. T2, final temperature of the gas. So that's how that one goes. Then the last one, second to the last one, draw the graph of Charles law. Similar thing. We have graph of Charles law like this. You see it. You start from here, broken line, then straight this one. This is volume, right? This is temperature, Kelvin. Remember this minus 273, which is also called absolute zero. Absolute zero is the temperature at which no gas can go below it. So that is where it is. So this is the graph of Charles law. Then the other one is a given mass of gas at 300 Kelvin occupies a volume of 220 centimeter cube. Find the temperature at which the volume was increased to this. You just use it, say V1 over T1, V2 over T2, where V1, T1, V2, T2. V1 is 200 cm cube at 300 Kelvin. Find the temperature at which the volume was increased to this. Temperature volume was increased to 300 Kelvin. I hope we are okay. A given mass of gas at 300 Kelvin occupies a volume of 220. A volume of 220. Find the temperature at which the volume is increased to 300 cm cube. Find the temperature at which it's increased to 300 cm cube. Sorry for that. So this is what we have. The next thing to substitute. V1 220 over T1 300. V2 300 over T2. You cross multiply. T2 times 220 equals 300 times 300, which is T2 equals 300 times 300 over 220, which gives, let's see how it goes. 300 times 300 give you, divide by 220, give you 409.09. 409.09 Kelvin. Sometimes they may tell you to express your answer in degrees Celsius. You just remove 273, but very rare, because the SI unit to use the measurement now is the Kelvin. So let's just go through briefly. Give mass of gas 300 Kelvin, volume 220, volume again is 300. So this is how you go about it. So this is how you carry out calculation that involves Charles law. Please always endeavor to understand properly before you start solving any question involving these laws. You have to check whether there is temperature. Once there is temperature, you know it can never be Boyle's law anymore. But if there is no temperature, you only have volume and pressure, you know it's Boyle's law. Thank you very much for watching my video. Please do well to subscribe. Like I told you last time, share it to your friends. Your friends, many of you told me that you have so many friends in different platforms. Do love, show love to them. Until like giving love. For God so loved the world that he gave his only begotten son. God started love. We also should spread love. Share it to your friends. God bless you.